Hi everyone, my name is Anna and I was one of the participants of the EuCAPT school that was held in Valencia in the auditorium of the Botanical Garden between the 18th and 22nd of September 2023. The main focus of the school was cosmology, but there were a lot of different topics from modified gravity and inflation to primordial black holes and the stochastic gravitational wave background, for example. What I really liked about the school was that there were a lot of speakers from different countries and universities, but also the students were from all over Europe. So this allowed us to get in contact with each other, talk about our experiences and our points of view on the matter, basically. Um, I also liked that the topics were quite broad, and there was also a soft skill training at the end of each day, including, for instance, science journalism and communication. And last but not least, I really like the fact that I got the opportunity of visiting a new city, which is always nice, of course. Now, I'm briefly going to explain a topic that I was particularly interested in, which is primordial black holes. So first, I have to say that I'm going to skip some explanation of basic concepts of inflation, for example. So some things may not be completely clear, but of course, I invite you to look up the things that I'm going to talk about. So first of all, what are primordial black holes? Well, they are black holes that are formed by the collapse of primordial overdensities in the radiation-dominated universe, and this means shortly after the Big Bang. And they're particularly interesting because right now, today, they are considered one of the dark matter candidates. So that's why it's important to study them and, um, study them more in depth. So we can usually describe these objects with this quantity delta that I put over here, which represents the fractional energy density. And it's important because if this quantity delta is higher than a critical value, this delta C, then the overdensity in our primordial universe collapses and the primordial black hole is created. So today, calculations tell us that these overdensities need to be large for the primordial black hole to be created. So now we might wonder if there is actually a mechanism able to create such large overdensities. And the answer is yes, and the right conditions happen during inflation. And in particular, we need to put ourselves in a particular case, an approximation that is called ultra slow roll inflation. So basically, this approximation says that the spatial derivative of the potential can be ignored, so it needs to be zero. And if the fluctuations of the scalar field enter the horizon during ultra-slow roll inflation, then they increase in size once they re-enter the horizons. And this means that large overdensities can be created and primordial black holes are born as a consequence. Now, when I say that the fluctuation re-enters the horizon, it means that mathematically its wave number k is equal to AH, where A is the scale factor and H is the Hubble parameter. While physically, it means that the fluctuations have become large enough for their effects to be observable and their influence on the evolution of cosmic structures to be actually observed. So these can be seen in this sketch right here, which is probably familiar to some of you. And from the experimental side, I want to briefly explain what are the ways we have to test the idea of primordial black holes that because this idea hasn't been tested yet or confirmed better. So you can see here a sketch of this R as a function of the mass. And R represents the ratio of black holes that can be dark matter. So a ratio of 1 means that all dark matter is made of primordial black holes. And we can see here in the red regions, these are the regions where there are no observed effects of primordial black holes. Using these three ways of probing this idea, which are primordial black hole evaporation, because small black holes evaporate via Hawking radiation. Then we have microlensing, which is basically it basically consists on observing how the luminosity of stars is influenced by the presence of a primordial black hole between us and the star itself. And then we have the most promising probe, especially in the next few years, which is gravitational waves. In the sketch, you can also see the constraints from the LIGO-Virgo-Cagra collaboration. And what we're interested in is are the frequencies of gravitational waves created by these primordial black holes. Indeed, primordial black holes, when they are formed, they enhance the primordial gravitational waves from inflation, and the frequencies of these gravitational waves will hopefully be probed by the next generation experiments like LISA. And these gravitational waves will allow us to probe also the primordial black holes in this green region that you see, which are asteroid-sized primordial black holes. Now, this was a short introduction to the short review of primordial black holes. Thank you for your attention. I hope you enjoyed this presentation on the EuCAPT school. And if you're thinking about it, I really invite you to join the school next year, because I'm sure it will be a great experience as it was for me.